In today's lesson, we're going to take a look more at linear relations, the idea that we have lines. We're going to look at the different kinds of lines we can have. There are two different big ideas today. Two names we're going to have to try and recognize. Name number one is partial, and name number two is direct. And these are both lines, but they're different kinds of lines. There's a couple ways you can recognize them. Okay, start with direct. Direct ones are always multiples of each other. So for instance, if I saw y equals 3x, and whenever I make my table for this one, I get 0, 0, 1 times it by 3, you get 3, 2 and 6, 3 and 9. They're direct multiples of each other. If you graph it, it always goes through the origin, 0, 0, because that's your first point. And on a graph, you go through the 0 and 0 point. And every equation looks like the one that I just showed you, y equals something times x. Okay, so this would be an example of one. This would be an example of one. Even this would be an example of one, because we know the number 1's in front. Okay, they're just direct multiples of each other. The other option has been called a partial variation. In this case, this is kind of the ones we've been dealing with over and over again. We have an initial value, something, plus the multiple. Okay. So you can always see if you have a plus or minus sign in your equation, that this is going to be a partial variation. These ones, because they have an initial value, always start somewhere besides its 0, like up there, or here, or there. Okay. They're not starting down here in the corner. Okay. They take the equation that we've been noticing. Okay. So some examples. 3 minus 2x. We can do some weird stuff with this. Let's say that 2x plus 7. That's still the same thing. It's just out of order. That's the exact same thing as this. The order is not important. The signs and the numbers are, but those are actually the same things. And we call these these ones that have initial values, we call them partial variations. That's our big idea today. Can we recognize the two different types of lines? Okay, so let's take a look at some examples here. So all we're going to do in these questions is set them up. Write some lat statements. That's what your x and y stands for. Make an equation, and then tell me if it's partial or direct, which you can tell from the equation in their format. So let's try the first one. A taxi driver charges $6 plus $0.05 per kilometer, or in other words, 5 cents. What do I not know? Well, x will be my number of kilometers, and as that changes, so does the cost. Right, what is our equation? Well, it starts at $6 plus 0.05 for every kilometer. What kind of question is this? Well, because I have an initial value, I don't start at 0, it means it has to be partial. Okay, it's more than just a multiple. Try B. Dave charges $12 per hour to cut your lawn. X equals the number of, in this case, the number of lawns. And as the number of lawns changes, so does the cost, or how much he gets paid. That's our equation. Well, this time, he doesn't get any money if he doesn't cut any lawns. So this one is just 12 for every lawn. There is no initial, so it means it must be direct. And just straight up multiply. Try C. Now at this point, I would pause it, see if you can get this one yourself, okay? Okay, cheese pizza start $9, and every topping is 75 cents. That sounds awfully like the first one, right? Number of toppings. Y has to be the cost. Notice that money is almost always our Y value. Okay, what do pizza start at? $9, and they go up 75 cents for every topping. We have an initial value, so it must be a partial equation. There's my initial. And the last one, D. Nature's Best sells bird seeds for 86 cents per kilogram. So my number of kilograms, my cost, 86 cents every time it's buy one. There's no initial value. You don't buy any. It doesn't cost you anything, which means this one must be direct. Okay, let's take it and put it all together now. So we have a graph. We talked about graphs, we talked about tables. This graph represents a relationship between the amount of money in a bank account in years, and time in years. So what is the initial value? This is what we've always done. My initial value is the first point to my graph when the number of is 0. In this case, it's $100. B, what's the rate? Okay, how do we do rates from a graph? We draw ourselves a nice triangle with nice numbers. So we definitely have the nice number at 100 right here. We've got to find some other point that I definitely know the coordinates of. So for instance, this one's at 1,006. I know both numbers, 6 and 1,000. Okay, what's next with our triangle? We have to go up from 100 to 1,000, so up 900. That goes on the top. It's our rise. And over, and we had to go over this far, and we said that was 6 years. Okay, it's $900. 6 years. If we divide it, that would be $150 per year. That's how fast this bank account is growing. A little bit every year. Okay, part C is make the equation. C. X equals number of years. Y equals amount. Our equation, we started at 100, which was in the bank, and then we started adding 150 every year. Okay, is it partial or direct? How do you know? We know that now. It's definitely partial. And our explanation why, it has an initial value. How much? Right there, $100, right? Okay, last one. Assuming the relationship doesn't change, how much money would be in the account after 25 years? So thinking about my equation, x is my number of years. If I know that x is 25, I can take my equation and replace the x with 25. Do some dead mass. 25 times 150 is a big number. 3,750. Put them together and we get $3,850  25 years time. Okay, we'll try one more example here. A theater group has posters printed for performance. The cost to print a poster is the sum of a fixed cost. In other words, it has an initial and a variable cost. So in other words, there's a rate. So we're talking about partial things right here. We know that right off the bat. It costs $75 to print 100 posters and $150 to do 400 posters. We want to graph this. So I've started the graph for you. On the bottom is my number of posters. And I gave you a scale. So 100, 200, 300, 400, 500. Up the side is our cost. 50, 75, 100, 120, 150, 175, 200, 225. It's all patterns, right? Okay, what do we know? $75 for 100 posters. So there's a dot right there. 100 posters, $75. 400 posters is 150. 400, 150, right there. So I graph the information. That's all it asked me to do. And what is the fixed cost? Well, how can I figure this out? Well, if I have a graph and it follows a pattern, then I can use a ruler to actually figure out my fixed cost. How can I do that? Well, we know these make lines. If I have two dots and I join them together, and I extend my line, oops, a little bit more here, then my line has to go through the initial value, which in this case happens to be right here. It has to start at $50. If I know something's a line, I can find the initial value just drawing my line. Okay, how do you determine from this graph? Draw the line. All right, part C. What is the rate of change? Well, we now do rates. We use our triangle method. So we're going to go up and over. How much did we go up? We went from 75 up to 150. How much did we go over? We went from 100, that's this number, over to 400. So it's 300. Put that stuff in here. Move it out of the way. So up 75 over 300 units and 300 posters. And if we divide that one, it should come out to 25 cents per poster. Let's guess. The next question probably be writing an equation. Sure is. D, X equals number of posters, Y equals cost. Our equation started at, well, on our graph it was 50, and it's going up 25 cents for every poster. Okay, last one, let's use that equation, right? How much does it cost to print 250 posters? Well, X is my number of posters. If X is 250, then I can say Y equals 50 plus 0.25 times 250. We'll do our bed mass. It comes out to $112.50. And the question has said, how'd you find out? So we use our equation, but there's something else we could have done. If I wanted 250 posters, 250 is right here. If I go up to the graph, I can kind of estimate what that is too, right? Halfway between 100 and 125. Guess what? 112.50. Okay. Okay, there's partial and direct. Oh, by the way, what kind of question would this be? It'd be partial rate has an initial value. That's kind of our big idea for today. Try the sheet on the website. If you're stuck, come see me.